Okay, so who has a side pair that works? Yep. And what's my last side? To TE. Good. And then my angles, they're just going to go in order. So I know angle M is congruent to angle T. Angle O is congruent to angle U. Angle N is congruent to angle E. Okay. So in the next couple, we haven't done, in years past, we had done transformations right before this. I'm not going to worry much about that. But we are going to practice something that may look different. Your statements may look different on your page than they do on my page. So I'm not going to get too much into the transformations, but what happens here is this is a flip or a reflection. Okay, over the y-axis. So I've taken this triangle and I just flipped it over. Okay, that's the transformation that happened. And so I know that this side, okay, that AB side, if I flip it over, now that's here. Okay, that this side flipped over or reflected over matches here. And that this side matches to this side. So you may be asked to write a congruency statement. So given a diagram, state the triangles that are congruent. Write a congruency statement. Congruent statement. So one statement that I could say is I could say triangle CAB is congruent to triangle. So order matters, right? CAB. So I have to go in the same order over here. What would that go to? TRS. T to R to S. Okay. CAB in my mind, the way I'm looking at that because I've color coded it, is I'm starting at the intersection of pink and blue, and I'm going up blue, down yellow, up blue, down yellow. So I do the same on the other side. So I do think the colors help their matching parts up. But could there be another way that I could write what triangle is congruent to what? What if I hadn't started at C? What if I had started at A? I could say triangle what? ABC, sure. And triangle ABC would not be congruent to this TRS, it would be congruent to what? RST, okay? So your response on homework, quizzes, or tests, it may be a different order, okay? But the order matters in terms of you have to make sure that you're, that was a weird way to write my explanation point. You have to make sure that you're matching up your corresponding sides. So I may match up in a different order, but in the end, A and R end up in the same spot. Okay, that B and S end up in the same spot, and C and T. Okay, C and T are in the same spot here, they're in the same spot there. Just happens to be the first spot versus the last spot. Okay, so just kind of know as you're checking homework or looking at notes on the days you're not here, the way I choose to write that statement may be a little different than the way you choose to write that statement, and that's okay, as long as the letters kind of match up the same. Okay, so you can always check like, okay, C and T, A goes to R and B goes to S. That's the easiest way to check if you wrote the statement correctly. This is a rotation. So it's been rotated around. Maybe I started here and rotated this way. But let's see. This side would match here. This side matching here. And then my last side matching here. So who can give me one congruent statement? And again, there's three different ways really that I could write this from one triangle to the other. So RST, R to S to T is congruent to A to B to C, agree. Triangle ABC. And just matching up the sides that match and the angles that match. And there's other ways that you could write it. That's just one option of how to write a congruency statement. Okay, good. So let's look at how we will see this in our work, how we use congruent triangles. This is almost like an algebra piece, this one. So it says, given the following congruent triangles, which means I know they're congruent. Knowing that they're congruent tells me that all of the corresponding parts are equal, same amount, okay, same length or same angle measurement. Now it kind of flips things around here. That's what the tick marks are for. So this one tick mark here matches this side. The two tick marks here match the two tick marks there. So that's how I can set up my equations for this one, is saying, okay, well, 7x minus 4 matches the side that's 31. Okay, there's one equation to solve for x. So then I know 7x equals 35 and x equals 5. And then I have 3 tick marks goes to 3 tick marks. So I can kind of put those together and say that 4y plus 8 then is congruent or equal to 24. And I'll be able to solve for y. So I subtract 8. And 4y equals 16. Divide by 4. And y equals 4. So that's one way that maybe we're presented with a problem and it matches it up using tick marks. It won't always use tick marks though. Many times it will use a congruency statement to help you match the parts up. So I'm given 2 triangles here. It doesn't match things up the way it does up above, but what it does do is it gives us this congruency statement. And this is what allows us to match up the correct pieces, okay? So if I know that triangle MAS is congruent to triangle MER, then I know that MA, which is from here to here, is corresponding to NE, okay? And I know that AS is congruent to ER. Okay, and then my last side obviously would match up here as well. Now, a lot of the problems here involve the angles. So I know, given a congruency statement, I know my sides, but I also know my angles. It tells me that angle M must be congruent to angle N, and that angle A must be congruent to angle E, and that angle S must be congruent to angle R. Okay, so I also know that, and I can use that to solve for different variables as well. Now, I can't really start with my sides. The only variable that I have for my sides is right here. I have 3x plus 5y, which I know will correspond to 41, because those are my corresponding sides. Why can't I start there? There's 2 variables. So I need to start somewhere else. So I'm looking for another variable. Where's my other variable piece? Which angle? Angle E. So the other place I have a variable is right here, angle E. Now angle E is congruent to angle A. Okay? Angle E is congruent to angle A. I know that because of this statement. It tells me which ones match up. Okay? So I know that 16x equals 112. Okay? And then I divide by 16 and x equals 7 maybe? 7. Okay. So first I had to find x. Now that I know what x is, I could even rewrite this. X is 7, right? So really I have 3 times 7 plus 5y. I have 21 plus 5y for that side. I'm just going to rewrite it, filling in what x is. And I know, because this statement, I know what matches with what. I know that that 21 plus 5y is equal to this side, which is 41. Okay, and now I can solve for y. So subtract 21, 5y equals 20, and y equals 4. So this page kind of almost does level 1, level 2, level 3. So level 1 is my diagram's marked for me. I just need to match it up. Okay, pretty direct what matches with what. Level 2 is my diagram's not marked for me, but I am given a diagram and I'm given this statement which helps me match things up. Level 3, this last one, is I'm not given a diagram. I'm just given the congruency statement. So I know that JKL is congruent to TRS. I don't need a diagram because if I have the statement, then I know what sides and what angles match up. Let me just put that. I know what sides and I know what angles match up. I did it on the other page. So then it tells me that KL is 4x and RS is 2x plus 12. Let's find x and KL. Well, what do we know about KL and RS? They're congruent because they're in the same spot in my statement. KL matches with RS. So I know that 4x is equal to 2x plus 12. Okay, the congruency statement is what allows me to know that that's true. So now you go ahead on your own, solve for x, and then find KL.
So 126 is better than
Tomorrow. I think it posted today, right?
Yes. We start it or do we
You'll
not?
have time to start it, yeah, because we're gonna trudge through like another part and then I'm gonna give people time to get caught up on stuff. So you'll have time. Okay, so what did you get for x? 6. And so how do I find KL? Right, so KL is 4x, and if x is 6, then I'm just plugging that in, and so I get 24 for the length of KL. Okay, now that is, I was just kind of checking, I think I'm correct in saying this. That is essentially what you will see on homework 26, but we will talk about it before I kind of set you to do some work. This is actually what we were supposed to do on Friday before break. But we didn't do it. I didn't post the notes that I posted in the classroom today. So that was supposed to be Friday stuff. I'm actually glad we waited till today, so it's nice and fresh as we start the unit. So we are going to kind of trudge forward, but not do all of these next notes, but just kind of start them so that tomorrow we can get going right into proofs. Okay, so we're just going to do the beginning part of this. Kind of introduce this is the important stuff for this unit. So we do use that first stuff as like, hey, we know they're congruent, so we can do all this algebra work, solve for different parts. What the bulk of this unit is about, however, is how can we prove that two triangles are congruent? So if I'm not just being told, say this triangle is congruent to this triangle, how could I say that they're congruent? I don't actually need to know that all of their parts are congruent to say they are. So if you kind of read this paragraph, it says, when we know that two triangles are congruent, their corresponding angles and sides are congruent. That's what we were just using. If we knew they were congruent, then we know all these pieces match up. But we don't need to verify that all of their parts are congruent. Okay, we can prove two triangles are congruent using the following rules. So there are certain ways that we can say, hey, because these things are true, that's enough for me to say all of the parts must match. And kind of the rule here is we always need 3 pieces of information. Okay, that's the key. Always need 3. And it's not just any three. There are some three pieces of information that won't help us, but there are specific ones that will. So our first one is side, 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 or SSS, right? If I knew that all three sides were congruent, if I was given the following information, that HE is congruent to MA, boom, boom, and that EY was congruent to AN, and I also knew that HY was congruent to MN. This matches with this. Okay, if I was either given that, or if during my proof I somehow was able to say that those three sides are congruent, if I have that, then my triangles are congruent. So triangle HEY would be congruent to triangle what? MAN. Triangle Hey is congruent to triangle man. Hey man. Okay. So that's one way. Well, why do we care if we only have those three things? Okay, that's enough to say these are congruent. So now I also know that all the angles must be congruent. Even though it didn't tell me that, or I wasn't given that, if I know that triangles are congruent, then I know all the parts match. So I could go even further with that triangle without having to tell me that. Side, side, side. Other ways is if it went side, angle, side. Now there's an important piece for the next two. Side, angle, side, in order for that to be the case that we have, it has to be the angle in between the two sides. So I can't just be given any two sides and an angle in a triangle. It has to be a side, then the angle, and then another side. So let me show you in an example here. So if I'm given, again, HE is congruent to MA. And I'll go ahead to the other side and say EY is congruent to AN. If I knew those two sides, the angle I would want would be the one between those two sides. If I was also given that angle E is congruent to angle A, only then would I have side, angle, side. If it was a different angle, if it was this angle or this angle, it wouldn't be the same. So to determine which one I have, I actually just look at one triangle. So if I cover this triangle and I go in order, it's side, angle, side. If I had been given this angle, it would be side, side, angle. Doesn't work the same. Okay, so it has to go in that order where it's the angle between them. And so if that's true, then my triangles are congruent. And Hey is congruent to man. And again, why do we care? Well, now we know all the other parts are congruent as well. So we can do more things. Really similar for the last one. So the last one is angle, side, angle. Again, it has to be the side between the angles. So if I'm given, for example, angle H is congruent to angle M. H, M. And angle Y is congruent to angle N. The only side that I would be desiring to be able to prove here is that HY and MN are the same, because then it goes angle, side, in the middle of them, angle. Okay, that is the only side that will work. This side with this side, because it is the side between those angles. Any other side would not work out the same. Okay, it has to be between. Triangle Hey then must be congruent to triangle man. Okay, that is enough. So there's 3 pieces of information we need. We add more ways that we can prove them congruent later on. But those are kind of the big 3. They're the most common ones. Side, 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 side angle, side, and angle, side, angle. And those are the 3 big ways to prove that triangles are congruent. Now, do you think that it's always just going to give us all the information we need? No, it's not going to. So we have to remember some stuff from units before now. Okay, so flip this over when we're ready. Here are the 3 ways we can use. Side, 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 side angle, side, angle, side, angle. There's one big one that we can never use. Not use side, side, angle. Okay, ever. It will never pop up that we will be able to use that. Now, one really easy way to remember that that's a no-go is if I went the other way around and instead of going side, side, angle, I listed that as angle, side, side, which it also is. I purposely didn't write it as angle, side, side because then it would be a naughty word, okay, and I wouldn't write that up there. But for the most part, if you are trying to prove triangles congruent and you're like, oh, that's a swear word, like that's a nope, can't use it. Don't say
It
it.
also means donkey.
It also means donkey.
Come on.
You know, in the South, they can't say butt at school, or my nieces can't say butt, which is what's funny to me. Like we read a book that had butt in it. It was a children's book, like a hippo's butt. And she was like, oh, I was like, this butt, what's wrong? They would get in trouble. I think they do call them sir and ma'am because she calls me ma'am. Yeah. And I can call her not to.
I think the professor would be like the only thing I could.
Professor.
The professor.
I don't know if they do. I'll ask them.
What if your last name starts with an X and you were you should call yourself Professor X?
Yeah.
That should be your name.
All right, so we're gonna look at these diagrams and then decide why it's one of those 3 or maybe it's not. Maybe they're not congruent. But obviously it's not just gonna give it to us. So our first one, this is included in it. C is the midpoint of BE. Okay. It gives us this diagram. It obviously doesn't give us enough. Okay. If C is the midpoint of BE, what does that mean is true? C is the midpoint of BE. What does midpoint mean? It's in the middle. So it's telling us this, which allows us to say that BC is congruent to CE, right? That I could label this like that. Okay, so it gives us a piece we know about midpoint. So if C is the midpoint of BE, then we can say BC is congruent to CE, which in a proof, we would then write our reason is definition of midpoint. Okay, so if this was a proof, and that's what I was given. And so what I am given, by the way, is that AC and CD are congruent. It's giving me that in the diagram. So right now I have 2 things. I have 2 sides. I need 3 things. What's the third thing here that's congruent? I don't know anything about AB and ED. What about angles? In that middle, that cross, yeah, these are vertical angles. Remember, vertical angles are congruent. So it gives us this diagram, and we know from past learning that that kind of crisscross creates vertical angles, and that I can say that angle, now they're both angle C. So I can't just say C is congruent to C. So I'll say ACB, this angle over here, ACB, is congruent to this angle over here, DCB. DCE, I should say, because they are vertical angles. So again, if I was writing a proof, and that was the diagram that was given to me, then in the proof, I would need to state that these angles are congruent because they're vertical. It's like I would need to state this because that's what midpoint is. Now I have 3 things. Are they an okay set of three things. Do I have either side, 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 side angle, side, or angle, side, angle? Which one do I have? Yeah. Cut it down to one triangle. I think that's the easiest way to do it. And then just go in order. Side, angle, side. Okay. So I know that they are congruent by side, angle, side. So I can say triangle ABC is congruent. And again, your statement may be in a different order. So I went ABC has to go DEC by side, angle, side. Okay, so I'd be able to say that those triangles are congruent by side, angle, side.
Whenever I think, this is gonna be a problem for me, because whenever I think of SSS, I always think immediately to that.
Yeah, just don't do that.
Yeah.
Just don't do that. Just think about, yeah, just think about sides.
It'll be fine.
The next one's a lot easier because it gives me 2 points or two things, not points, 2 things. So I have these sides match and these sides match. And I'm not doing on the angles. They share a side here. What is that called in our proof when they share a side? So would you agree to me that this side in that triangle is the same as this side in that triangle, right? Because they're sharing it, right? So it's fine to mark that. So I know that DT is congruent to DT, which is the reflexive property. So again, if we were writing a proof, and that was the diagrams given to me, but from that, I have to know what to look for. 2 of the biggest, what I call look fors here, are vertical angles and reflexive property. They show up all the time with congruent triangles. If I have vertical angles or reflexive property, I got to state it in my proof. Okay. Now that I have that, I'm going to say that triangle ADT is congruent to triangle EDT. Again, order matters, so I was careful to go in the same order. By what property? Look at just one triangle. Side, side, side. Side, side, side. Now the next one, there's nothing tricky here. They're 2 totally separate triangles, so I'm not going to have vertical or reflexive going on. Okay, notice those are like mushed, what I call mushed together triangles. The diagram's all one, and there's vertical in one, reflexive in the other. These aren't mushed. These are their own little independent triangles. We wouldn't have reflexive or vertical angles in independent triangles. These what it. Are these triangles congruent, given the markings on them? Yeah, they are. Okay, and there's 2 ways that we could say that they are congruent. Now let's be really careful with how we label this. So I'm going to go in order, like 1 tick mark, 2 tick marks, 3 tick marks. So CTA would be congruent to triangle what? Careful. So CTA goes 1 tick mark, 2 tick mark. So I have to flip it around. Yeah, I have to go GDO because that's 1 tick mark, 2 tick marks. You see what I mean? Like how you use those to help you organize it. So what's one? There's 2 things that I could use here. What's one? Yeah, so one thing I have, because I have that 90-degree angle, again, I just need to look at one. I have side, angle, side here. Or I could use side, side, side. They also have 3 sides match. So by side, angle, side, or side, side, side. They are just super congruent. There's 2 ways I can say that they're congruent. Independent triangles. So I wouldn't have reflexive or vertical. I do have 3 things marked here. I have an angle, followed by a side, followed by I'm leaving a large space here, another side. Ah, can I use that? No, don't do that. Okay. Yeah, this So it wouldn't, you know, look so aggressive on the page. I didn't want to be too aggressive with my geometry notes.
For high school.
Hey, it's like as.
You've always said.
No, those could be congruent, but with the information we have, I can't say that they are, okay? So that's kind of where you can see, hey, look at that, we go into proofs. Next, not gonna do it today. Day one back from vacation, we're not insane, okay? So what I am going to give you time to do, let me pause this.